Lesson 10.3 is finding vertical asymptotes algebraically. What is an asymptote? Well, there's actually vertical asymptotes, horizontal asymptotes, and sometimes even slant asymptotes. But today we're just talking about vertical ones. But an asymptote is a line that a curve approaches but never actually touches. So we said that rational functions will make these weird graphs where they have a lot of curved or hyperbolas, curved lines. But any asymptote is not really going to show up on your graph. It's just this imaginary line that, see, as this function goes down, it's actually going to keep going down and getting closer and closer to this dashed line, but it will never actually touch. It's crazy. It just doesn't. And then the same graph here, this would increase, and it would get closer and closer and closer to this imaginary line, but it never has an x value of 1. So this vertical asymptote is actually at x is 1. See that? So that's what an asymptote is. It's just somewhere that the graph does not exist, and it happens to be some kind of vertical line. So the way to do this algebraically without graphing, you're going to factor the numerator and the denominator somehow, cancel if you have any common factors, and then set the simplified denominator to 0 and solve. So number 1, if I were to factor this numerator, both terms have a 2x I could factor out, and this would have times an x minus 1. And you could always distribute to check. That would make 2x squared minus 2x. Okay, on the denominator, both terms have a 3 I can divide out. That would leave me with an x minus 1. So x minus 1's cancel. This actually results in a whole, but we're not ready for that yet. So now I'm going to write my simplified function as what's left over, which is 2x divided by 3. I'm setting the denominator equal to 0 and solving. I can't solve if there's no x to solve for, right? 3 does not equal 0 ever. So this has no asymptote. I'll say no vertical asymptote. And this will have, I think, a drop-down menu where you pick how many or something, or you would leave it blank. I can't remember, but it does not have a vertical asymptote. All right, number 2. I can factor the denominator. I could take out a 3 again. That would be x minus 1. But nothing cancels. And so there's no whole, but I would just either need to put this equal to 0 or this. I kind of like back to the original just because, but then I could still set this x minus 1. The answer is going to be 1 because look, I add 3 over, divide by 3, x is 1. That's your vertical asymptote. And sometimes I abbreviate it with VA, so I'll put the vertical asymptote at x equals 1. That would be what like this graph was like. All right, number 3. And the numerator, before I jump to slide and divide, I have to check for GCF. All of these numbers are even, so I'm going to take out a 2. That would leave me with x squared plus 12x plus 32. The denominator is just a basic trinomial. So that must be x times x. The numbers would be -9 and +8. I need to also factor this again. So that would be 8 and 4. Cancel the common factors of x plus 8. That would be, there's something with a hole there, but we're not worried about it. New function or simplified function is 2 times x plus 4 over just x minus 9. So what can't x be? Positive 9. That's setting it equal to 0 and solving. So there's a vertical asymptote at x equals 9. And then number 4, kind of similar. I would take out a 2. Have x squared minus 13x plus 30. On the bottom, I can't take out anything, so this has to get factored with slide and divide. That would be x squared minus 17x plus 60. Factor that. Two negatives would be -15 and -2 divided by 3. Okay. So on the top, I have 2 times, I have to factor again. That would be -10 and -3. And on the bottom, I have x minus 5 and 3x minus 2. Did I do everything right? Yeah. Okay, so I did all that factoring kind of for nothing because nothing cancels, so there's no holes. But I'm actually going to get 2 different vertical asymptotes, which can happen. So I'm just setting each factor equal to 0 and solving. This one would be at 5. This one would be at positive 2/3. If you can't solve that in your head, you'll have to show the work. So 2 different vertical asymptotes.